Good morning, students. Jai Swaminarayan. Today we are going to do the definition of permutation. What is permutation? And before starting permutation, let us revise the fundamental principle of counting. Suppose an event can occur in n different ways. After that, the second event can occur in n different ways. And after that, the third event can occur in p different ways. Then, the total number of ways in which all the three events can occur in order. The total number of ways in which all the three different events can occur in order one after the other are nothing but n into p. Students, this is the fundamental principle of counting. All of you know we have done this. Now students, in a slightly different way, exactly slightly different way, we are going to present the fundamental principle of counting in the form of permutation. Let us take an example to understand the definition. Say I have digits 3, 4, 5, 7, 8 and 9. Say given are 6 digits 3, 4, 5, 7, 8 and 9. Using these 6 digits, I want to form 3 digits number. So the arranged digits I call as R and total digits I call as N. R stands for arranged. So students, I am drawing 3 boxes. This is hundreds place, this is tens place, and this is units place. So total students, I am drawing 3 boxes, and 0 is not a digit, plus repetition of digit is not allowed. Students, what is not allowed is repetition of digits. Now I can start from either one. I am starting from hundreds place. In hundreds place, out of 6 digits, anyone can come. So the hundreds place can be students arranged in how many ways? 6 ways. Suppose 7 is already arranged. So for tens place, I have only now 5 options. So the tens place can be selected in 5 ways. And after that, 9 is arranged. So the units place can be arranged in how many ways? Then I can say 4 ways. So the total number of ways in which 3 digits can be arranged are 6, 5 and 4. So this is 30 into 4. So 120 ways. Absolutely right, students. This was fundamental principle of counting only, nothing else. Now I am doing this in a slightly different way, but it is very similar to FPC, and that FPC is nothing but students' fundamental principle of counting. The hundreds place can be filled in n ways, n minus 0 ways. I can write 6 as 6 minus 0, n 6. So now I am coming to generalization. Total I have n digits, out of which I am arranging r digits. So the first place of r digits can be arranged in n ways. After that, this is first place, this is second place, and this is third place. After that, the second place can be filled in n minus 1 ways. Third place can be filled in n minus 2 ways. Now pay attention. This is the third place, and that is r. This 4 can be understood as 6 minus 3 plus 1. Pay attention. First place can be filled in n minus 0. Second place n minus 1. This is one less than the place. So the rth place can be filled in n minus r minus 1, which is nothing but n minus r plus 1. This r is equal to 3 as per our example in general. So given are n objects, items or things out of which r items are to be arranged, then the first of the r items can be arranged in n ways, second item can be arranged in n minus 1 ways, third item can be arranged in n minus 2 ways, last the rth item can be arranged in n minus r minus 1. The subtraction is one less than the number of places, so the rth place can be filled in n minus r minus 1 ways. Therefore, the total ways in which all the places can be arranged are n into n minus 1 into n minus 2 up to n minus r plus 1, and this is nothing but NPR, that is permutation. So, given are n items, objects or numbers or digits, using that digits or items or objects we want to fill r places, then the total ways in which these r things or items or objects can be arranged out of given n are n into n minus 1 into n minus 2 up to n minus r plus 1. This is called permutation. So what is permutation? Given are n items, objects or things out of which we have to arrange r objects. So out of given n objects, r objects can be arranged in NPR ways, and that is nothing but permutation. So what is the formal definition of permutation? Out of given n objects, the total ways in which r items can be arranged out of n is called permutation of r items. It is denoted by the symbol NPR. N stands for total items, P stands for permutation, R stands for arranged items or objects. So students, try to understand the definition of permutation. Once again, the total ways in which R things out of given n things can be arranged is called permutation of R things, and it is denoted by NPR. In this NPR, N stands for total items, P stands for permutations, and R stands for arranged items or objects. And the formula of permutation is nothing but NPR is equal to n into n minus 1 into n minus 2 into n minus 3 up to n minus r plus 1. So students, the key word for permutation is arrangement. So the last time I am revising the definition, the total arrangements of n things out of given, the total number of r things out of given n things, the total arrangements of r things out of given n things is called permutation of r things, denoted by NPR. And students, the formula for permutation is NPR is equal to n into n minus 1 into n minus 2 up to n minus r plus 1. The same sum I am doing using formula. N is 6, P is r is 3 and P as it is. So n means 6, n minus 1 means 6 minus 1, and n minus r plus 1. We have to arrange only 3. So this is 6 minus 3 plus 1. So the answer is 6, 5, 4, and this is equal to 120. The same answer I got here, which was using fundamental principle of counting. So in summary, out of given n things, r things can be arranged in NPR ways, and NPR is called permutation of r things out of given n things, and r can be 0, between 0 and n, including n. R can never be negative, and r can never be more than n. Given are 6 digits, and I can never arrange 7 digits. So the range of r is between 0 and n, including n. Strictly speaking or frankly speaking, even it can be 0, but that makes no sense. So, permutation is always based on arrangement, and out of given n things, r things can be arranged in a row in NPR ways, and this total ways are called permutations of r things given n at a time. The formula for permutation is NPR is equal to n into n minus 1 into n minus 2 up to n minus r plus 1. Okay students, having done this today, next concept which we are going to do, and that concept is nothing but students the concept of factorial. After permutation, now our next thing down to do is the concept of factorial. Now students, what is factorial? Suppose I made 5 factorial. This symbol of exclamation mark denotes factorial. But don't read this as students 5 exclamation. Read this as 5 factorial. Students, don't read this as 5 exclamation. Read this as 5 factorial. 5 factorial is nothing but the product of first 5 natural numbers, and it is 120. If I write 3 factorial, it is product of first 3 natural numbers, which is 6. If I write 2 factorial, it is product of first 2 natural numbers, which is 2. In general, if I write n factorial, it is product of first n natural numbers. It is product of first n natural numbers. So what is the definition of n factorial? Then definitely we can say the product of first n natural numbers is defined as n factorial. The product of first n natural numbers is defined as n factorial. So in the factorial notation we have always natural numbers. Exceptions are always there. 0 factorial is 1. 0 is not a natural number, but students, this is an exception. 0 is not a natural number. Exceptions are always there. So we have to remember that 0 factorial is nothing but 1. So once again, the last time we are revising the definition of factorial. The product of first n natural numbers is called students n factorial. The product of first 5 natural numbers is defined as 5 factorial. The product of first 100 natural numbers is defined as 100 factorial. Exception 0 factorial students is equal to 1. Now students, pay attention. In the simplification of factorial, one has to be very careful because this is multiplication of numbers, and especially these natural numbers. Okay students, now let us do exercise 7.2. We are starting exercise 7.2. It is a very simple exercise. Answer 1. Evaluate the following. Find the value of that. The first part is 8 factorial. So 8 factorial. Students, product I can write in any order. I am writing 8, 7, 6, 5, 4, 3, 2, 1. Multiplication is commutative. Even if I write product of 1 to 8, or students, if I write product of 8 to 1 natural numbers, the concept remains the same. So multiply this. Then students, 6 factorial. This is 56 and this is 7. when we multiply, whatever you get is your answer. That's what I leave for you to complete. So students, 8 factorial is the product of first 8 natural numbers. 8 factorial is the product of first 8 natural numbers. Second, I know the answer, I am not telling, it will be 40,000 something. Now, second is 4 factorial minus 3 factorial. Never read this as 4 exclamation minus 3 exclamation, students. One has to be very careful. Now, 4 factorial minus 3 factorial is not 1 factorial. So be careful. First of all, I will omit 4 factorial. 4 factorial is product of first 4 natural numbers. And 3 factorial is product of first 3 natural numbers. So 24 minus 6. So the answer is 8. Check. You would have written 1 factorial. 1 factorial is simply 1. And that is definitely wrong, students. So, this is the definition of factorial which we have applied. Okay, students, next concept is to do question 2. Remember, we have an exception that 0 factorial, students, is always equal to 1. Now, in the second sum, verify that is 3 factorial plus 4 factorial, 7 factorial or not. Is this true or not? 3 factorial plus 4 factorial is equal to 7 factorial. Students, we are told to verify this. Is this result true? Is LHS equal to RHS or not? That, students, we have to check. So first I will simplify LHS. Is this true? It is a question. LHS is equal to 3 factorial plus 4 factorial. This is product of 3 to 1. This is product of 4, 3 to 1. This is 6. This is 24. So this is 30. Now, RHS is 7 factorial. So this is product of 7, 6, 5, 4, 3, 2, 1. And this is 5, 0, 4, 0. Multiply and check. So definitely, students, therefore LHS not equal to RHS. Therefore 3 factorial plus 4 factorial is equal to 7 factorial is not true. That's all, students. This much only we have to do. Now for doing questions 3 and 4, students, we have to understand one very important aspect of factorial. Students, this is like puzzle. This chapter is like puzzle, which is, you can say, frequently applied in day-to-day life. Now say, students, I have 8 factorial. It is product of 8, 7, 6, 5, 4, 3, 2, 1. I put here bracket. This is what? According to definition, this is product of first 7 natural numbers. So I can write this as 8 into 7 factorial. Now, if I further reduce like this, then 7 factorial can be written as 7 into 6 factorial. Yes or no? Again, if I further reduce this, I can write 6 factorial as 6 into 5 factorial, like that. We go on reducing. So, in general, n factorial is written as n into n minus 1 factorial. N minus 1 factorial is written as n minus 1 into n minus 2 factorial. X factorial is written as x into x minus 1 factorial. So, this is how, students, we go for the basics of factorial simplification. So, if it is 10 factorial, then I can write this as 10 into 9 factorial. If it is 9 factorial, I can write this as 9 into 8 factorial. If it is 8 factorial, I can write this as 8 into 7 factorial, like that. So, our answer 3 is to simplify, get the value. So, find the value of 8 factorial divided by 6 factorial into 2 factorial. So, we have to find the value of 8 factorial upon 6 factorial into 2 factorial. Now, the logic of simplifying factorial is very interesting, students. The logic of simplifying factorial is very interesting. Reduce 8 up to 6. So, I can write 8 into 7 into 6 factorial. I have shown here. Keeping 6 factorial intact and 2 factorial is 2. Now, similar factorial terms x cancel, 2 ones are 2 fours are. So, the answer is 7 fours are 28. So, whenever we have factorial terms in division, the logic or the concept of simplification works like this. Always reduce the greater factorial terms up to the lower factorial terms and get it cancelled. The logic goes like this, students. Always reduce the greater factorial terms up to the smaller factorial term and get it cancelled. Now, students, answer number 4, we have to find x from a given equation. The given equation is 1 upon 6 factorial plus 1 upon 7 factorial is equal to x upon 8 factorial. This is what, students, we have to simplify. This is the given equation. We are given this equation. So, first of all, check what factorial terms we have. We have 3 factorial terms, 6 factorial, 7 factorial and 8. Greatest is 8 and least is 6. So, simplify greater factorial terms up to smaller. So, my 6 factorial is base, keeping as it is. 7 factorial is 7 into 6, so I got 8 factorial is 8 into 7 into 6. Now, take 6 factorial common from both the sides and we get it cancelled. So, 1 plus 1 by 7 is equal to x by 56 into 6 factorial. 6 factorial and 6 factorial gets cancelled. 1 plus 1 by 7 is 8 by 7 is equal to x by 56. So, x is equal to 56 into 8 by 7. 7 ones are 7 eights are. So, this answer is 64. So, the logic of simplifying equation involving factorial is always simplify and reduce the greater factorial terms up to the smaller factorial term and get it cancelled. This is our answer, students. Now, we are doing sum number 5 and today only we will complete, students, exercise 7.2. Now, the first part of the sum given is n is equal to 6 and r is equal to 2. Given is n is equal to 6 and r is equal to 2. We have to find value of n factorial upon n minus r factorial. In the second case, n is 9, r is equal to 5. We have to again find value of n factorial upon n minus r factorial. Now students, here n is 6, n minus r means 6 minus 2 factorial. So this is 6 factorial upon 4 factorial. Now just now, students, I have explained. Just now, students, I have explained. Reduce the greater factorial term up to the smaller factorial term and get it cancelled out of 6 and 4. 6 is greater than reducing 6 by 2. So this 30 is your answer. Even if you do the derivative, 6 factorial is 720 and 4 factorial is 24, and then you divide, then also your answer will be 30. If the number is very big, like 16 factorial, 20 factorial, or 29 factorial, then finding factorial is very difficult job. So this is written as 9 factorial and this is 9 minus 5. So this is written as 9 factorial upon 4. Reduce 9 into 4. So 9, 8, 7, 6, 5, 4. Upon 4, 4 factorial gets cancelled. So 9 gives us 72 into 42 into 5. Multiply this. Whatever number you get, that is your answer, students. So, this exercise is completed. This concept is, students, a very easy concept once you understand. So, let us revise the 3 definitions before concluding the lecture. First definition, of course, is of permutation. The total arrangements of R things out of given n things is called permutation of R things. Permutation is denoted by NPR, and the formula for permutation is NPR is equal to n into n minus 1 into n minus 2 up to n minus r plus 1. Then students, factorial. What is factorial? The product of first n natural numbers is defined as, students, n factorial, and the formula for n factorial is multiplication of 1, 2, 3 into n natural numbers. In general, n factorial is the product of first n natural numbers. We have an exception that 0 factorial is equal to 1. Then students, once again let us revise the definition of 7.1. What is fundamental principle of counting? Suppose an event can occur in n different ways. After that, the second event can occur in n different ways, and correspondingly the third event can occur in 3 different ways. Then the total number of ways in which both the in which all the 3 events can occur in order is nothing but n into p. This principle is called fundamental principle of counting. In the notation n, p, r, all of you know n stands for total items given, p stands for permutation, and r stands for arranged items or objects. Range of r is between 0 and n, including n. R can never be a value greater than So students, this is what we have studied. Again, exceptions are always there in mathematics. We have to accept those exceptions, and the best ever possible exception in this particular topic is 0 factorial is equal to 1. Students, we have to understand, remember and memorize that 0 factorial is equal to 1, even though 0 is not a natural number, but we have exception that 0 factorial is equal to 1. So in exercise 7.1 and 7.2, students, we have, you can say, understood the basics of fundamental principle of counting. What is the definition of permutation? What is the definition of factorial? Even though factorials, or even though the definitions are not asked, but students try to memorize and write these definitions minimum twice. And the best ever exception for factorial, that 0 factorial, students, is equal to 1. So students, having completed 7.1 and 7.2, here we conclude our lecture. Remaining we will do in the next lecture. Thank you, students.